A couple of people asked earlier, since I kind of flew through this. This is the QR code for the new website for Encoding Equity. I also went around at lunch and gave people the one pager as well. But it's the place to go and sign up. Let us know how you'd like to stay engaged. So with that, if you guys want to pull up the slides for this session, that would be cool. You guys can pull up the slides for the session if you'd like. Thank you so much. So I'm really delighted. We have had so many conversations this morning that sort of touched on, well, what's the role of AI? What's the role of machine learning? And I think we're now going to hear it from some remarkable set of experts, really thinking about how particularly you could use AI and machine learning to mitigate harm, right? It's been a lot of discussion about how it can be harmful. There are also opportunities here, I think, to use it as a tool to actually reduce harm and mitigate harm. So delighted that we have Dr. Kameron Matthews, who is the Chief Health Officer of Cityblock Health, a remarkable value-based program that really uses technology to help some of our most vulnerable patients in extraordinary ways. I think she's also now the incoming or soon-to-be chair of one of the committees for CHI, the Provider Health System Committee. So whether she likes it or not, she's going to be totally steeped in AI, and I told her this was a good start. So Kameron's going to introduce the panel, and thank you all.
Thank you so much, Helen. Hi, everybody. Yes, this is the post-lunch conversation. Let's do this together. Stretch if you need to. Get up and stand at the back like I often do. I get it. But I'm really excited and grateful to be a part of today's convening. Not necessarily as much of an expert at all as also with our prior panel, but really more so as a stakeholder. My lens in this disruptor space, as we're often called at Cityblock, versus, well, along with my role as a family doc, as a primary care clinician, who obviously is quite invested in primary care being more fully recognized as a solution in and of itself. How can we actually think about AI and machine learning to help us in the practice environment is definitely where my leaning will be in the advisory board work with CHI. But again, I'm Kameron Matthews. I've been Chief Health Officer with Cityblock for a couple of years now. And for those of you who don't recognize what Cityblock is, we are a transformative advanced primary care practice that takes on full risk value-based care. And in that, we are focused on Medicaid and dually eligible populations. So in that, we are obviously focused on health equity. We are obviously really seeking to bring about as much data-driven and tech-enabled support for these populations that are typically not the audience when we're actually pulling a lot of these tools and resources together. But I'm really proud that we're leaning into not just general tech enablement, but also AI-supported algorithms, even within our space. Within our tech stack in general, we're considering a handful of different solutions. But the idea, of course, is to expand our capabilities. We have a dwindling primary care workforce, as we all know. So how can we not only support appropriate decision support for our patients, but then also really bolster the day-to-day operations for our care teams? My number one question on a day-to-day basis is always, how do I support my care teams? Because they're the ones actually doing the work and actually addressing the equity concerns that we've been talking about all day today. So we're really proud in Cityblock. We've actually built out an AI-supported member segmentation algorithm. And for those of you who are familiar with value-based care, it's, of course, an approach to population health where you actually really need to be thinking across the board. You need to be as data-driven as possible. And so we stratify our members so that we understand kind of the intensity. We actually say the dose of Cityblock that they need and their types of needs, because we need to understand how can we apply our very limited resources in order to actually improve their outcomes. But clearly bias is steeped in all that we do, and that's actually the conversation that we're going to have today. And so within our algorithm, we've actually sought and are actually validating it currently to be quite intentional about minimizing bias, about making sure that we have several different approaches. So we're using industry standard scores that other population health management functions are using. So fully validated, we're not recreating the wheel in any sort of way, but we're specifically choosing those tools that are appropriate for our population. So number one, we're not basing things, as has been shown, on past utilization. For marginalized communities, you in and of yourself have to, in every way, make sure you're understanding that access and trust are obviously reflected. Those social drivers are reflected in all that we do for our marginalized communities. But we also are choosing only those tools that are agnostic of cost as well, particularly when you're thinking through the different parameters in which our members are seeking out care. Cost is often a unfortunately skewed factor as well that actually exacerbates the bias. So we've been purposeful in how we're building this out. We, our data science team, and I'm just learning, but we as a team have been quite purposeful about how we've been doing this and how we're going to actually then assess whether bias is occurring within our populations, how we're going to potentially address that bias through some additionally applied post-processing sort of logic to our algorithms. And then, of course, as we're looking at additional new algorithms, I mean, we have several predictive models in place for our behavioral health work, for our maternity work, and the like. How we're actually choosing these algorithms, we're of course, seeking out additional criteria to make sure that our models are sound and appropriately based on the communities that we're serving. So using us as an example, I mean, obviously we're doing this in this microcosm compared to the larger impact that our conversation can really achieve today. And as we've seen throughout the day, I am very excited to hopefully be able to ask some questions, but I'm going to encourage everybody like we did this morning to line up at the mics and definitely send in online. But I'm absolutely excited to introduce these three experts who are joining me today and are going to give us considerable amount of insight on how we're actually going to approach bias and mitigate harm within the work around AI. So I've got Tina Hernandez-Boussard, our Associate Dean of Research and Professor of Medicine at Stanford University. I've got Dr. Brian Anderson, our Chief Executive Officer of the Coalition for Health AI. And then Dr. Shyam Visweswaran, Professor of Biomedical Informatics at the University of Pittsburgh. So, Tina, why don't you take it away?
All right. Okay, can you hear me? Wonderful. So thank you so much for this opportunity to be here and share some of the work we've been doing. I wear two hats. I am a professor of medicine in biomedical informatics, where my team works on the application of algorithms to health and healthcare. And so in that application, we think about how do we think about bias? How do we evaluate bias? How do we think about the responsible use of AI? And then I'm also Associate Dean of Research, where we're developing the infrastructure so that our researchers across the School of Medicine can do the efficient amount of tests and analyses before we even think about moving these to point of care. So there we go. So today I want to talk about the regulatory environment and how that impacts so much that we do in thinking about bias and mitigation strategies. And I think it's important to take a step back and understand, we know healthcare is complex and AI technologies are evolving at a pace that we just can't keep up with. There's various regulations and guidelines to help us govern the development and use of AI, but they're various, they're at multiple levels, and some of them are contradicting. So navigating that system is really complex. And then you probably all heard about this trade-off between AI performance and equity, right? And so in the past, I think we've really focused on the performance of algorithms. So you look at any paper, the first thing they report is area under the curve, the ROC curve. This model is so great at, discriminating between diseased and non-diseased. But we haven't really put enough emphasis on the equity, the fairness, and the bias in these algorithms. So this is a shift we're making over these past couple of years, but it's important to understand when we promote equity, we're taking a hit in performance. And so who's making those decisions as to what are we prioritizing? How are we setting these thresholds? Is something that we're still figuring out, and there's a lot more research needed in that. And then importantly, in the regulatory environment, I think industry is working behind closed doors in a lot of senses. And so you can't have this talk without talking about large language models today. And so in the past, we've really known what large language models have been trained on. They've been trained on things like PubMed, MedWiki. And so we know, for example, the models trained on PubMed, we know what's missing, right? We're only seeing positive results. We're not seeing any of the negative experiments. And so we can take that information into account when we're analyzing these to think about what are we looking for biases, where might we have concerns. But with the newer large language models, the 7 billion parameters, we no longer know what they're trained on. Right, so we get some tidbits of information, scraping of YouTube, maybe some synthetic data in there. So they're starting to work behind closed doors, which really complicates the situation when we think about we're all trying to use large language models in practice. We're thinking about the enormous potential, but how do we start thinking about biases? Because in this environment, we cannot retrain a large language model. We cannot go back and understand what data is being used. So how do you think about the guardrails we put up when using those models? So just to set the stage for where I'm going. And so, when we think about the regulatory environment, there's a lot of rules guiding how we think about the regulatory use and development of AI. There's the Bill of Rights that came out last year that's really the guiding principles. The FDA also has a software as a medical device, where there are also principles in how we think about regulating AI in healthcare. In addition, we're going to talk a little bit about HHS's new rule, the 1557, and the scope for discrimination protections. But then we also have local government initiatives. So I just want to shout out, there was a new sweeping bill in Colorado that just came into legislation, and it's really the first of a kind where the state is holding developers accountable. And so I wanted to show you that. So understanding all these different layers of regulatory environment helps us think about how we can start mitigating these biases. So the Bill of Rights, there are 5 principles. I'm not going to go into that. But I think that what's important is there's a principle on algorithmic discrimination protections. So in the Bill of Rights, they state that there has to be equity considerations that address the holistic impact, right? Holistic impact of AI on underserved communities. They also have a clause in there that we need continuous measures, and we need to proactively look at equity assessments and testing. Okay, so that kind of sets the stage for where we're going. And then we have the FDA framework. And the FDA framework for assessing software as a medical device is really based on the way they've done drugs, right? It is a risk assessment of the state of the healthcare situation, and then how the algorithm is used. Is it used to treat and diagnose, to drive clinical management, or just to inform management? And so nowhere in here is anything about equity or bias or generalizability of these algorithms. And so in 2021, the FDA put out a ruling on general good machine learning practices. It lacked any information about guidance on bias and fairness. And so if my FDA colleagues are in here, please correct me if things are different. And then in 2021, they also put out an action, same time, a call to action that, yes, they do need to assess these biases and fairnesses. So some conflicting information, which really complicates things when we go to navigate. And more recently, so in fact, this was just last month, the FDA put out a call for transparency for machine learning enabled medical devices. And really they're looking at the who, the why, the what, the where, and the how for machine learning practices. So when we talk about transparency, transparency for who? why do we need it to be transparent? What needs to be transparent? So there's been a lot of work thinking about how we think about transparency and automating that. And so model cards and Hugging Face model cards are something that are becoming more systematic in the machine learning community. And these are applications that automatically, in some sense, systematically produce this information on transparency. What was your training data? What evaluation metrics are you looking at? Who's your population? So a lot of work coming out on how we think about transparency and how this is going to drive equity. And then more recently, we had a workshop at NIH where a lot of people in this crowd were there also, thinking about, how do we think about transparency for data and model reuse? And it was a workshop, and this was really focused on data and model reuse for equity and how we think about that. And I think also in this workshop, we came out that, we really need standards and tools for transparency, because when I say transparency, my definition might be completely different from somebody else's definition. Industry has a different definition of transparency than other, possibly than other for-profit entities. So we need to think about standards and tools for transparency, systematically generating this information. Again, thinking about that holistic life cycle, as Helen talked about earlier. And also there's this need for distributed accountability, right? Building responsible data and model use requires distributed accountability. So the model developers are responsible for reporting what they're doing. The model implementers are responsible for thinking about how do they set up continuous monitoring. And more importantly, we need to think about how do patient outcomes fit in this framework of accountability. And we also talked a lot about Hugging Face cards and different types of model cards and data sheets, which really are a way to think about how we are transparent about the models we're developing, the data they're trained on, and can we make this a requirement moving forward so that it's systematically apparent. So we don't have to spend 5 years digging into these algorithms to understand, well, what data were they used to train on? Is my population represented in this algorithm? How do I know when to apply this into my healthcare system? So I want to get into this latest rule from the 1557 to clarifying scope of discrimination and protections. And so this is really a great movement that really strengthens our ability to monitor, to evaluate, and to ensure that the clinical algorithms we're developing are not discriminatory in any means. It prohibits discrimination based on race, color, national origin, age, disability, etc., across all covered health programs and activities of HHS. So that's very broad scoping. It includes patient decision support tools, and it also includes restoration of protections for the LGBTQI and pregnant individuals. So really important wording on how we think about discrimination. And more importantly, it requires that covered entities take steps to identify and mitigate discrimination when they use AI or other forms of decision support. So this is about that accountability piece, right? Spreading that accountability. It's not just up to the developers and the data scientists to ensure equity and non-discrimination, but it's also up to the people deploying these algorithms, right? So it really is shifting this accountability across all stakeholders. And so there are some key provisions in the final rule, as I mentioned, the non-discriminatory standards, but there's also rulings on discrimination against language and accessibility services. There's information on telehealth accessibility, and also, again, as I mentioned, on the LGBTQI protections. So broad scoping rules on discrimination that really set the stage for where we're going and how we think about these clinical decision support tools, how we need to evaluate them, and how we think about deploying them across populations. And this is some work that Helen cited this also, but this was cited as some guiding principles for how we think about monitoring fairness in our clinical decision support tools. And this is some work, as was mentioned earlier, that was a very large collaboration. And we really identified, we were looking at the AI lifecycle, and we're like, this is great. We have all these different components in the AI lifecycle, but what are the guiding principles we need to use to ensure that the algorithms we're developed are fair and non-discriminatory? And so, we need to be promoting health. It depends on the questions we're asking. Are we asking the right questions? Are the questions we're using to solve with AI really promoting health and healthcare equity, ensuring stakeholder involvement, understanding the trade-off issues between fairness and equity? So a lot of great principles here. I'm going to skip over that. Sorry. So another piece in the rule was we're going to dismantle race-based medicine. And so we've heard a lot of talks about that today, and this is some work that we did with Helen and Shazi and Maya Hightower, who's not here today, thinking about what does it mean, what does race-based medicine mean, and how do we think about dismantling it, right? How do we think about structural racism that gets encoded in our algorithms? How do we include better social determinants of health, and also that cultural awareness? We also talked about how we advance health equity with AI technology, and this is something we talked about a lot. I don't think it made it into the final article, but we thought there were 4 main pillars for really advancing health equity with AI technology. And the very first, and this was mentioned last talk, increasing trial diversity, right? Because our clinical guidelines, the information we use to develop our algorithms are based on clinical guidelines. So without trial diversity, we just can't have that information we need to understand what are the driving factors that are causally related to differences in the outcomes we're seeing across care. We need to move from precision medicine to precision care, which means taking into account patient values, social determinants of health, care goals, et cetera. We need to think more about promoting education and awareness about health equity, discrimination in AI algorithms, and how that gets incorporated into our healthcare system. And finally, developing guidelines and policies, which we've talked about. This is my last piece I want to throw out. So I want to highlight, Governor Polis's letter from May 2024, he sent out a letter that said, if you're going to develop AI in the state of Colorado, you have to have a compliance regime development. You have to have a framework for how you're going to report the discriminatory aspects of that algorithm to the state, to the stakeholders, to the people. There's a notification and reporting requirements, but more importantly, there's these pieces on it's their developers' responsibility to do these guidelines and develop and assessments to know how it's equitable or how it's not. So I think we're moving in this direction. I'm thinking some of my other colleagues are going to talk more about what are the standards and guidelines, what are the metrics we're achieving for, because we still have no consensus on that. And I'll end with this from, I think somebody said this earlier, biased algorithms are easier to fix than biased people. So I'll stop there.
That's great. Great job. All right. So I'm Brian Anderson. I'm CEO for Coalition for Health AI. And let's see here if we can advance the slide. Oh, give him a second. Okay. While he's pulling the slide up, I'll start by sharing a little bit about Chai. So Chai started 3 years ago as a coalition of the willing. In the middle of the pandemic, you had a lot of non-traditional, inherently competitive organizations working together during the pandemic, right? Building vaccines, therapeutics, trying to solve the challenges that were in front of us. And a number of us during that time began realizing the value that groups that were inherently competitive, what we could do together. And so we came together and we asked, is there something that we could be doing in AI that could benefit society, that could benefit all of us? And one of the basic first questions we asked was very much tied to what Tina had identified. Are there consensus frameworks or definitions around what good, responsible AI in health looks like? And the answer we quickly came to was there's not. To Tina's point on one of her first slides, there's a lot of good work being done in closed doors in individual organizations developing responsible AI best practices and processes, but not at a consensus level across organizations. And in a consequential space like health, where people's lives are on the line, we believe that that was a real problem and that that was an opportunity for the health systems, the clinicians that first started CHI, that we could come together with patient community advocates, with a broader representation of stakeholders from society to begin building what is the definition of responsible AI in health. And another, to Tina's point, what are some of those specific definitions for metrics like fairness and bias and transparency, right? We know what area under the curve is, right? That's a mathematical thing and people can publish that and there's agreement on that. What there is not agreement on, what does bias look like in an LLM? How do you measure reliability in an LLM? What does transparency mean? To Tina's point, it could mean one thing to her, one thing to me. When you have such consequential stakes on the line, we need to have consensus around that. And so that is what the genesis story of CHI was, is bringing together at a very high level the creators of AI. So these are like the technology companies, the startups, big tech and small tech. We have over 2,500 organizations in CHI. The users of AI, so these are oftentimes health systems, the procurers, the customers that buy the model from the technology company, or the payer that buys the model from the technology company. And importantly, the target of the models, all of us, patients. Every one of us is a patient or a consumer, and we need to be able to have our voice as part of the conversation in how these tools are being developed. And so that, in a nutshell, is what these 2,300, actually this slide is now out of date, it's 2,500 members in CHI. So 4 basic things that we're focused on. These technical frameworks or technical standards that are adherent to the FAAFP principles, which if you want to read more about, you can go into the Office of the National Coordinator, Health TI 1 rule. But in essence, it's that technical, granular, specific definition about what responsible AI principles look like at a technical level that would inform a software developer or an MLOps manager at any of the various life cycle stages for a model, be its development, its deployment, or its maintenance and monitoring. What does that technical framework look like? The other part of CHI, and this is, I think, where we've had a lot of animated conversations, is around this concept of quality assurance labs, and I'll get to it in a second in a little more detail. But in essence, taking that technical definition, once you have a consensus, objective definition of what good is, you can then evaluate a model's alignment or misalignment to that definition. If I have a metric that can measure fairness or bias for any one specific ethnic group or social class, I can then objectively enable independent entities to do that kind of evaluation. One of the pillars in the White House's proposed AI Bill of Rights, the safety and effectiveness pillar, specifically calls out the need for independent evaluation of AI models. That is something that we see in every sector of consequence in society: aerospace, automotive industry, consumer electrical device industry. We don't have that in AI. In CHI, we believe that is a real problem. We need to be able to have those kinds of safeguards for our patients, for our society. The third area, and this is, I think, one of the real important principles, both in responsible AI, but also just generally, when you want to build trust, you need transparency. So one of the things we're committed to in CHI, this quality assurance network of labs, one of the requirements of these labs is every model that goes through these labs and has an evaluation report to be issued is going to be published in a national registry. So if you're familiar with clinicaltrials.gov, hopefully our website will be a little bit more user-friendly. No offense to any of my NIH colleagues in the room. But we want a registry where people can go, patients, community members, customers of AI, technology vendors of AI can go and say, how are these models working, right? I'm a Native American. I live in the Boston area. I go to MGH. I want to be able to go to this registry and look at the models that are deployed at MGH and see how those models perform on Native Americans. I want to be able to be empowered to have a conversation with my provider and say, maybe you shouldn't use that model because look at the AUC score on people like me. That's what we're trying to enable with this kind of transparency. And then finally, there is a dearth of information and education for providers, for clinicians, for doctors, for people in general around what responsible AI means. I talk to doctors every day that are faced with the challenge of, I don't know if this tool, this AI tool that I have in front of me, is fit for purpose for the patient. How do I critically evaluate that? How do I think about that? I hear people talking about model cards. I don't know what that means. And so we're committed to building out a suite of educational materials within CHI that can support a broader awareness around how to think critically about AI, because it's only in doing that that I think we get to, Helen, I think the hope and aspiration of mitigating the risk for discrimination and bias in AI. We got to educate all of us to be able to think critically about these tools and their use. So how are we doing that? So at a high level, last year we published a blueprint, very similar to the White House's blueprint. It's not technically specific enough. It is a PDF document. Next week, I'm very excited, we will be announcing our assurance standards guide and our checklist. That will be coming out on the 26th. These are highly technical documents, over 150 pages. If you're interested in reading them, stay tuned for that. But these get to the level of specificity around what assurance looks like at the various stages of a model's life cycle. Additionally, in CHI, we've launched several working groups. We've launched 5 so far. We're going to launch a total of about 19 by the end of the year. These working groups are large. They're intentionally large to be inclusive of a lot of voices. And the end deliverable is going to be these technical frameworks and what those metrics are. Because, right, we urgently need to be able to have a common definition around what bias looks like. If we want to mitigate bias, we got to be able to define it and agree on what that definition of fairness is and how to transparently describe that. We have to have an agreed upon definition on what are the elements that go into a model card. So these working groups at that bottom layer are committed to being able to do that. Okay, so what does all of this enable? I talked about assurance labs. They're part of every segment of society that is of consequence. I mentioned a bunch of them. Automotive industry is probably one that you're familiar with, the Insurance Institute for Highway Safety, the famous car crash tests where a car crashes into a wall, airbags deploy, and what you don't hear about is the Insurance Institute and other entities measure the safety of cars objectively, independently of what the car manufacturer says. So that then, in that case, insurance company can determine what their premiums are going to be based for when we choose to have one of those cars. In the AI space, we don't have that yet. What we want to do, step 1, right, come up with the definition of what good looks like. Step 2, come up with the definition of what those metrics are to measure against that definition. Step 3 is enable a network of quality assurance labs that are trusted, that have high quality data, that have the expertise and tooling to actually do the hard work of evaluation. Now, when you think about a network of assurance labs or assurance labs in general, one of the unique challenges in health, I think that we'd all agree, is health data is very sensitive, right? It's very personal. I don't want my health data getting out. You don't want your health data getting out. And so the quandary becomes, how do we do evaluations of models on this data? You have to have a representative set of data. If we want to build AI that is going to serve all of us, we need to have data that is representative of all of us. And so what CHI is doing, we're building this network. It's a federated network. So there's not going to be some centralized, server in the bottom of some CHI office that's going to have everyone's data. It's federated. It's going to stay in the health systems where it's at. It's going to be de-identified. There are going to be certain provisions that are going to be required to be a certified lab that will ensure privacy, anonymity, and cybersecurity and safety from those guards. But the other important point is this data will be representative. There will be labs on the East Coast, on the West Coast, in the Southeast, in the North. The importance is that we want to enable that kind of independent evaluation so that if we have a model that is making a claim that it's going to identify breast cancer in African-American females of middle age, that we can go to an assurance lab that has longitudinal patient populations that are African-American of middle age and that have a robust sample and do a really meaningful, rigorous testing. And so, that's the vision, is to be able to support, and I have images here, from inner city Chicago to rural Appalachia to tribal nations, that kind of model evaluation. Now, I want to also make a point about local model monitoring, local recurrent monitoring. It is important to have objective definitions of what good looks like, to be able to objectively be able to evaluate something and describe that evaluation transparently at a national level or international level for all of us, to have a common definition of what good looks like. It is equally important to ensure that we're enabling local recurrent monitoring, local recurrent validation of a model once it's deployed. If I'm a health system on a tribal nation and I've bought or procured a model from a technology vendor and it met and passed the initial testing from the objective model assurance lab, once it's deployed, those models, their performance degrades, there's bias, there's drift, all sorts of confounding variables come into effect. Local recurrent validation using the kinds of tooling that is easily deployable, especially easily deployable to lower resourced segments of the society of health systems is really important. Also important, ensuring that these labs can support the kind of model validation that might be unique to a health system. Caroline, I see you here from the VA. We're talking to the VA. You have a unique population. You don't want the models in the VHA that are deployed to be biased or discriminatory against any of the unique populations in the VA or the warfighters in the DoD. So ensuring that health systems have their own quality assurance labs to do that local validation is incredibly critical. And that's one of the core tenets of CHI, is enabling external independent validation, just like the Bill of Rights that the White House proposed, but also local recurrent validation, empowering health systems to be able to monitor these models for all the performance degradation and drift. And it's in doing that that we can enable the kinds of mitigation of bias and discrimination. Tina ended on a great slide, and I want to call it out here. One of the things I oftentimes say is, all algorithms are, at a very high level, are programs trained on our histories. And you think about that, if you're from an underrepresented part of society like me, that doesn't sound too good. And yet, there's an opportunity if we, again, have a common agreement about what good is, and therefore what bad is, and a desire and a willingness and a motivation to get better, to make intentional effort to train our models, to improve our models, to remediate is one of the technical terms we use, our models, so that we are more in alignment with those guidelines of what fairness is, because we have a common definition of what bias metric looks like. I believe, and this is partly why I'm so excited, I believe we have an ability to address that bias, that hopeless bias that if at the end of the day, all we are satisfied with is models trained on our histories, I think we're going to be living in a much darker future than the opportunity that we have where we can take these models, know what good looks like, know what bad looks like, and develop the systems in place to shoot for that good. So that's my plea. Consider joining CHI. I'll end with, I should have probably ended on that slide because that was the best slide to end on. I'll end with what Tina just riffing a little bit on the changing regulatory landscape. One of the challenges that health systems face is the Office of Civil Rights Rules, Section 1557 that just came out, right? It puts all of the onus on the providers. Provider organizations are on the hook. They use a model, it's found to be discriminatory, they can get a lawsuit brought on them from OCR. No one wants that. And so what we're partnering with health systems is demanding the transparency of the model vendor to fill out the model card that HTI 1 rule came out with that says, what are your testing evaluations? If I'm a big health system, I want to know, is your model going to perform well on the patients I have? Before I make the procurement decision to deploy it, to use it, for my frontline clinicians to use it, I want you to fill out that testing and evaluation category in the model card so that I can make an informed decision. And so that's the kind of coalition and movement that we're building in CHI. All right, I'll stop there. Thanks.
Yep, so I should be one of the folks trying to join CHI from University of Pittsburgh. And
UPMC is already part of CHI.
sort of. but not from the academic side. Okay. So I'm going to start off where sort of what my role is. So I'm basically clinically trained, and then I trained in AI. And one of my research interests about 5 years ago started in deployment of AI-based decision support. And it sounded very nice at that time. And what I figured out pretty quickly was, one, Chai didn't exist at that time. So we don't have measures of performance and measures of implementation and so on and so forth. And secondly, it seemed like even for the statistical algorithms that have been used now for a while, we don't have many of these performance metrics. So it's sort of premature, I think, in some sense, not to consider the statistical algorithms and how we assess the performance and jump straight into AI. We kind of need these measures to be developed for these existing algorithms, as well as for these AI ones, which are going to come in the future. And so what I'll do is I'll talk a little bit about what Chai is actually trying to do, but this is sort of a baby step in terms of trying to even catalog what the space of these clinical algorithms which are there in use, specifically in terms of the use of race in them. And I'll specifically talk a little bit about the urinary tract infection algorithm that Dr. Wright had mentioned in the previous panel, and how we are trying to assess whether it's actually fair or not. And one of the points that you made was, now we have to figure out what goodness means, what fair means, and how do we measure it. And I'll show you a little bit of results which shows that it's not easy to know what's fair. So roughly speaking, so clinical algorithms, I think of them as both the statistical algorithms which were developed using standard statistical techniques, which are currently there in use. And we have seen a lot of this in the morning. And then now, as we go forward, we are going to be seeing AI ML models where the task is somewhat similar. You're trying to assess risk or prognosis. And really, the main difference between these two is the amount of variables and the amount of data which are being used to develop these algorithms. The statistical algorithms sort of use smaller amount of data, smaller number of variables. The AI ML models are using much, much more. And I want to make a pragmatic difference between these two. With the statistical models, they're typically published. And the derivation data, even though it may not be available, at least there's some description of it publicly available. And many of them are in extensive clinical use. And of course, there's a lot of ongoing efforts to evaluate bias, especially racial bias, and trying to fix it. And we have heard a lot of this in the morning about how some of the most commonly used ones are currently being reevaluated. With the AI ML models, and hopefully Chai will actually try to fix some of these issues, is the details of these models and derivation data are often not available. And there are over 500 FDA-certified health AI algorithms out there. And I don't think I can get my hands on any one of them in terms of their performance metrics. And so as a core tenet of transparency, we have to be able to fix that going forward. They're currently not in extensive clinical use, but they will be as we go forward. And the efforts to evaluate bias in them are sort of just beginning. So about a year and a half ago, one of the questions which sort of came up to me was, I was discussing with the developers of the UTI calc algorithm. And one of the questions which arose was that how many of such algorithms are out there which might be potentially biased in terms of use of race? And of course, the first thing is, at least the algorithms which have race as an input variable in it is a good starting point, because those obviously produce different outputs for different racial categories. And it's a good starting point to understand the space. And the literature really didn't have, other than a couple of papers which had listed examples of these algorithms, there was no comprehensive list. And so we basically went around and dug up a lot of websites, including MD Calc, looked at these algorithms and tabulated them. And so currently there are about 45 of these. I think we are up to 47 at this point. A lot of them are these risk calculators, which produce some sort of a score. There are also a small number of lab tests where the reference ranges that you use for decision making are different based on race. And there's at least one therapy recommendation, and this is for hypertension, where race-based guidelines are used to basically decide which is the best first-line agent to use. What is also interesting is as we were doing this, we came across the FDA inserts for medications. And if you go to this website, we actually have a second table which lists 15 medications where the FDA has got race-based guidelines in either testing levels of this medication or dosing the medication or even starting the medication. And this was news to us when we actually were doing this work. And more recently, the classical example of this is pulse oximetry. So there are devices which are biased too in terms of racial categories. So pulse oximetry came up during the COVID pandemic, and it measures basically the oxygen saturation. And it was noticed that for dark-skinned people, it was not well calibrated, and by the time they came to the hospital, they were actually pretty sick. And there are at least a bunch of other devices which use similar technology, like infrared thermometers, for example, which are also biased in the same way. One really interesting example is electroencephalogram, the electrodes which are used. These are disc electrodes, and they don't adhere to the scalp very well if you have very thick hair. And so African-American populations, the recordings that you get are often of poor quality. And as a side effect of this, well, in clinical care, sure, you have diagnostic problems because of that. But on the research setting, one of the side effects of this is that the poor data gets thrown out. And so almost all the EEG data sets which are out there for research purposes don't have essentially African-American data in it because they get thrown out. And so these have implications not only for clinical care, but also for research. So one of the things we also noticed is that when a new version of an algorithm comes, the old version disappears. And it seems that we need to track all these versions as we go along. So we basically need a story for each of these algorithms, which is freely available so that when researchers or developers go in, they don't have to start from scratch. And they can go and look at versions of the algorithm, see what was the problem with, say, a previous version and why was the new version developed. And sometimes it's not quite clear that the newer version is actually better than the older version. And so for those reasons alone, we should be able to track this, have a place where it's freely available. So that was sort of the genesis of this website. And so currently what it has is essentially a short description for these algorithms which have got race as an input variable. There is a link to an online implementation, often to MD Calc. There's some description of the use of race and the rationale for the use of race. It lists the variables which the algorithm uses, as well as it lists the values of the race ethnicity variable which is used. And then if there are new versions which are race-free versions, that's also listed. And so we didn't restrict ourselves just to the US. So there are algorithms from the UK and even from Japan in this. And one of the sort of obvious conclusions when we looked at the distinct race ethnicity values, there were 49 of them across these 45 or so algorithms. And of course, one big issue is that the values used in the UK are far more granular than the values which are used in the US. And the same label might mean very different things. So black in the UK means something very, very different, black in the US. The other things we noticed was there are at least these two values called other and mixed, which typically are probably unusable in the clinical world, but they are very frequently present in these calculators. And especially a label like other probably means completely different things from algorithm to algorithm. Well, even something like black probably means very different things depending on the country of origin. So having at least some understanding of the landscape of what we are dealing with is sort of important. And secondly, as work gets done in certain algorithms, then it is important that we can transfer this to other algorithms. So these are some additional stuff we want to do, and we really want to get into creating fairness profiles. And I'll give you an example of the challenges that we ran into this. And some of the things that you mentioned is also of interest, like model cards. So sort of an open source implementation is we are using this company called Health Universe where we can implement these algorithms. And it puts up a sort of a web-based version of this similar to MD Calc. And we implemented the UTI Calc out there. And then the code is sitting in GitHub, which people can access it, so that now you have coded versions of these algorithms which are available. So this is an example of a fairness profile that we did for one algorithm. This is the UTI Calc, and each column actually is a different model. The first column is version 1, which was the initial algorithm, which had race in it, and V3 is the most recent version of the algorithm, which doesn't have race in it. And then the intermediate ones are sort of are models that we have been playing around with for this same problem. And what the rows represent are essentially fairness metrics that's available in the literature. And typically, these are things like very familiar metrics like difference in sensitivity across the two groups, or difference in accuracy across the two groups, or difference in specificity, so on and so forth. And green means that the difference is really small and it's good. It's fair. And red means that the gap is much wider. So what's interesting is that if you look at the second row, which is looking at sensitivity, which is what this algorithm is designed for, it's a screening algorithm, so you want it to be very sensitive. The revised version, V3, is definitely much better than the version 1. And we just looked at sensitivity. But typically, when you optimize it for sensitivity, something else you give up. And what you give up here is positive predictive value. So actually, the revised version has got poorer positive predictive value, and it's unfair on positive predictive value. And so you do have to worry about how this algorithm gets used, that if people start using it beyond screening, but to start actually doing interventions directly, then it turns into a diagnostic algorithm, in which case you worry about PPV. So what this is basically indicating is that you cannot optimize simultaneously across all these metrics. And so this introduces complexity in terms of what users might think is this algorithm is fair. Someone has sort of decided it's fair. Well, you can't really make it fair for all possible conditions. So I'll talk a little bit about fairness. So the current fairness metrics, which was sort of listed in that slide, these are group fairness metrics, which means that these are statistics which are done at a population level or at a group level. So these are statistical measures, and they're in common use, but they don't guarantee that for a particular person, the algorithm actually is doing a good job. All it guarantees is that for that particular group, on average, it does okay. It doesn't guarantee that for that particular person, it actually does great. So there's this whole notion of individual fairness, which is starting to develop at this point. And the idea is that similar individuals should receive similar treatments or experience similar outcomes. The problem, of course, is that defining similarity between individuals is tricky. And right now, we don't have any standard measures which are available to measure individual fairness. But this is something I think we have to think about, because right now, we say fairness, and then Chai might settle down on a whole bunch of group fairness metrics, and everyone might decide, we are done. But it might turn out that no, we are not done, and we need to get into other fairness metrics. And the drawbacks of group fairness is that, as I mentioned, there are mathematical results which show that you cannot achieve fairness on all performance metrics simultaneously. And that can be problematic. As I mentioned, you have only group level guarantees. You really don't have guarantees at the individual level. And so it gets tricky because now you have to define what group. So you might define group on race, but there's no guarantee that it's fair on another group based on, say, socioeconomic status. And so if you have to do this for every possible of these protected variables, and then you have to think about intersectionality, then statistically this just blows this problem up. You're going to have too many groups, and you have to basically, it'll boil down to that there's a group with only one person in it, and then it just comes back to individual fairness at this point. And so the idea of individual fairness, and this is something which has been discussed quite a bit in the economic literature, in the philosophical literature, and in the justice literature, is really you have to define a group for this particular person who is similar to that group. And it has to be done almost on a person-to-person basis. And that's what clinicians do, right? When they're doing clinical diagnosis, they're really thinking of similar people to this person, and then they're figuring out what that similarity looks like. The key challenge is, of course, to derive the appropriate similarity metric by which to decide who is the peer group of people that we are going to use for this particular person. And there's a fair amount of work which is going on in the AI machine learning world called metric learning, which tries to automatically construct these task-specific similarity metrics. But a fair amount of work needs to be done in that space. But the basic idea here is to say that this complicates things, right? So we're all sitting here and we're saying, all we need to do is come up with appropriate metrics that we all agree on and we're done. But it might turn out there is no single canonical metric that is usable for every possible condition out there. And then you're stuck with, okay, what do we do now? And it brings up this issue of then it needs to be personalized to the context, to the person, to the race, to the gender, so on and so forth. And then it brings up the questions like, how do you even do this, right? So we're going to need AI to sort of personalize an existing model or an algorithm to be fair for this particular person. So the whole notion of fairness itself might not be sort of a single idea or a single number that applies to everybody, but actually changes from person to person. And there's a fair amount of work which has been done it comes mostly from the philosophy field, that the way you define fairness actually changes from person to person. It depends upon the lived conditions which you can change, as well as the things that you can change. And really, the society needs to compensate for the things that cannot be changed and needs to penalize for things that can be changed. And that can change from group to group and person to person. So, so I'll kind of stop there and say that in terms of having this grand idea of getting to a more fairer situation is great, but some of the devil is going to be in the details, and there might be math out there which says you can't do some of these things that you actually want to do.
All righty, I would love to see as many people as possible at these mics. But while we're live, oh, please, online, yeah.
Yeah, two questions in the same kind of general idea. For Dr. Matthews, are the models that you use open sourced and academically published, or are they commercial? And if they are commercial, are the models publicly accessible? And I'll let you answer that one before a related one.
Not yet, but we're pushing to get it into the literature.
And for Dr. Anderson, for National Registry, how can I, the questioner, as a patient, inquire into the effectiveness of models that are applied to me if I am not aware of what models I am subject to? What compels health systems to disclose what models are deployed?
Great question. So one of the requirements for the quality assurance labs in CHI will be to identify where those models are deployed. Meaning, so it's going to go through a lab, and what we're looking to do is because we have, I think, over 600 health systems, is we're going to be partnering with those health systems to list, essentially, in this registry where that model is deployed. And then you imagine, again, some kind of feature on the registry that allows an individual to drill down, into their location, specific attributes about themselves, and then to identify how that model at that location might be performing on them.
Okay, thank you. Excellent panel. My name is Kimani Toussaint, Brown University. Actually, in engineering, so slightly different community, but very important in terms of contributing to the conversation. A couple of things, questions and comments. One of the things that I'm wondering, that struck me, is that in the world of nanotechnology, smart manufacturing, material science, there's been a push for the last decade or so to basically make databases, right? And there is not an issue of PHI or anything of that sort, but when industry is involved, there is an issue of IP, right? So there are parallels there that people have been working on where they recognize the value of having data sets that are reliable, that can inform machines for making predictions, for whether it be for manufacturing 4.0 or something super cool with materials like the Materials Genome Project. And so one of the things I'm wondering is whether or not there is an eye towards not necessarily worrying about reinventing the wheel, but learning some best practices from totally different and disparate fields. So that's one quick point. The second point, I like the last speaker's comments because I was thinking of something similar. I think there is value in having a group fairness index for sure, when one probably tries to make some relative estimates about how to treat communities as a whole. But one of the things I know we were discussing, my table was discussing at lunchtime, was thinking about from the perspective of, and I think the first speaker may have mentioned this, or the second speaker, personalized medicine, and rethinking that definition of personalized medicine. Now, it is for sure a grand challenge, but one that goes beyond just the biochemical assays that one might advance, but includes the social context, right? So there's an ethics piece here. You mentioned philosophy. There is a social science piece to this that I'm for sure not versed in. There's a technology piece, there's a clinical piece. So thinking about how all of that holistically informs health may be informative with regards to how to think about the application of AI, for example. So I'm just throwing it out there, but I love the idea of perhaps being choosy, that not one tool necessarily fits all, and that it can be very situation dependent. There's a question hidden in there somewhere, so, so take your pick.
So I can go ahead and start, and then I'll pass along. So the one thing about having the group fairness metric is it reinforces stereotypes, right? Because we're saying you're part of this group, therefore you're going to respond to this treatment like everyone else, the average person in this group, and it takes away the part of individual fairness. So when we're thinking about the metrics, one thing that's been considered is, do you have different thresholds for different groups? And then I'm going to give this one to you, because how in a hospital can you have one algorithm, but then for each different group, you're going to have a different threshold for when you treat, when you don't treat. And so I don't think that's sustainable when we think about how to deal with this. And so it's interesting. And then just to talk about your point about the precision medicine. And so that is something we're talking about, like precision care, which is really genomics plus social determinants of health, plus environmental factors, plus your clinical information pulled into one. And so moving from I think that group realization, oh, you have this gene mutation and you are Blacks, therefore we're going here. I think we can take that definition farther and think about how do we pull in more pieces for precision care.
My response is going to be real quick. I think you can't have one model that's going to be predictive and
For
have
everyone.
for everyone. It has to be. They just have to be tailored.
So then how does a hospital tailor that? Like if within the same hospital, right, this is the challenge. Do you have one for Hispanics, one for Native Americans, one for Blacks? And then what does the clinician have to think about when they see the patient in front of them? Are they like making the call on,
Yeah.
on the spot? Oh, I think you're Black. So,
Well, this is where I would turn to someone like Daniel over there and ask him, what is Kaiser Permanente doing in a situation like that? It's a great question.
right?
Hi there. I'm Anjali Jan from the Agency for Healthcare Research and Quality, AHRQ. So we've been heavily engaged with some of this work and presented some. So I'm going to admit to some complexity and then ask a very oversimplified question. So in some of the work that Shazia presented, for example, we saw that you can have disparities independent of whether or not the race variable is included. And certainly that, even the same algorithm might have a benefit for one outcome and a harm from another, right? However, considering like we're spending a lot of time and effort appropriately kind of figuring out the black box of what's going on, especially with machine learning, but all kinds of algorithms and models, right? Is there potential to kind of reverse engineer and maybe the best or the most fair or the most right algorithm or model is the one that yields the best outcomes? And so it seems possible to me, I was an engineer a long time ago, that one could sort of start with the end in mind, in a sense, and then what do we need to do to get there? Can you speak to that on any level?
Yeah, I can probably offer some comments on that. It makes a lot of sense that you want to evaluate the algorithms on outcomes eventually. Right? What we really care about is outcomes for a specific person and outcomes for the population at large. And sort of all these intermediary variables with, say, race or gender probably fall away when you do that. The tricky part, I think, there is someone has to make a judgment call what's a good outcome and what's a bad outcome, right? You can do at a policy level, make some really abstract considerations like say, okay, prolonging life is the key outcome we care about. And you can optimize algorithms for that. But it may not fit everyone. There might be a lot of people who tell you, I've led a full life. I really don't want to have a lot more years. What I really want is a few more years which are comfortable. And so this gets down to basically eliciting utilities and preferences from the stakeholders. And that has to be brought into these models. So the models only get halfway to what you want. They just tell you what's the probability of various outcomes happening. But who decides which outcome is preferable to which? That can happen at the patient level, that can happen at the physician level, that can happen at the payer level, so on and so forth. And maybe that's one of the missing pieces that has to be brought in is that when these algorithms are developed and someone establishes a threshold, there is implicit value judgment going on inside that, which is sometimes not made explicit in these documents. Is what is it that you are valuing most based on which this algorithm has been optimized? And once you can do that, then you can tailor the algorithm. So you might have an algorithm which has been tailored for maximum longevity. But then maybe the patient in front of you says, that's not what I care about at this point. And then you can say, okay, this algorithm is not, this threshold is not acceptable for this person, and we can change the threshold. Because you can basically do decision analysis, and that's done all the time with high-stake decisions in business. And so that can be brought in.
Real quick.
I was just going to add, to make these decisions, you need to have the community and partnerships there, right? Because
Yeah.
my decision for what's a priority is going to be different than the healthcare systems, than the patients. So I really want to put that plug in for it's got to be a joint conversation.
Perfect. All right. Unfortunately, this is going to be our last question over here because we do need to go to small groups. Please go ahead.
Thank you. Bill Jordan with the American Medical Association. I guess on a couple of points. One is, and echoing some of Anjali's comments, how do we move from zero-sum thinking to a rising tide lifts all boats when we're thinking about these algorithms? And the second one being about how do we move from mitigation strategies to reparative strategies? So, when I think about the zero-sum thinking, it sounds like there's always, if we give something to one group, we're taking away from another. And so maybe it's about testing the application of the tools rather than testing the performance of the tools, thinking about like phase 1 versus phase 3 clinical trials or phase 2 versus phase 3. And then in terms of mitigation to reparation, like what is really the goal outcome of these? Because if we're just protecting against discrimination, we're not really moving towards, like, we might need to be developing the algorithms towards the world that we want to see and training on data of the world we want to see rather than the world that we had in the past.
That was going to be my question. Thank you. Please, I'd love to hear.
I can start. I think you're exactly on the last part. That's the vision that many of us have in Chai, is how do we build the intentional relationships with parts of our community that have been left out of telling their digital story. To build that future that we want collectively requires the hard work of data engineering and labeling and anonymization and partnering with communities and affirming ways to tell their story so that models can be trained on that data in a way that serves them. On the mitigation comment, one of the, I think, wonderful things that's overlooked about these quality assurance labs is, yes, they test and they validate, but they can also remediate and train and help models. Once you have a rigorous intentional structure in place to identify the blind spots, once those blind spots are identified, you can work to remediate the models, and you get into the hard world that Shyam is describing, where it's a balancing act between negative predictive value, positive predictive value, a bunch of different fairness algorithms and ways of measuring it, and you're not going to get it perfect, but at least you have transparency on it, and you have a rigorous structure to measure, and you know what the performance is in a more transparent way. And so that's, I think, one of the exciting things that we see in these labs is helping to remediate these models once we can identify some of the blind spots.
Informed decision.
Informed decision. Informed consent. Yeah.
Informed consent, yeah.
Thank you so much to our panel. Thanks, everyone.
Thank you.
Everybody gets to stand up. And participatory conversations to follow at the breakout session. So session 1, effective communication strategies. Session 2, fostering research and clinical collaborations. And session 3, technology as an equity enabler. Everybody sort of signed up initially. I will say I'm told that the technology one is full. The other 2 are still open. Knots after that. You guys are pretty into this whole AI discussion. Anyway, that's from 2:15 to 3:15. We'll then have a break, and we'll do our final fireside chat and wrap up. So please, all the sessions are to go out this door and down that hallway to the left. You will pass coffee and things on your way if you need them. And see you soon.
To our online participants, please come back.